listen again. Okay, thank you. Guys, so what we're going to do today, we've got a double lesson today. We're going to definitely do the whole time today. Maybe we'll steal a little bit from tomorrow, but we'll see how it goes. We're putting all the graphs together. Okay? So I started, and it did take me a while, drawing the graphs, so cosine, for sine, and a tan. Okay? I will chat about that for a couple of minutes. Add a little bit, at least one more thing about the tan, which I didn't mention yesterday. And then I'm going to just let you loose on exercise 13. Okay? Exercise 13, because we finished 12. Okay? Exercise 13. And we will go through all of the questions there, because graphs, trig graphs are not easy. It's your first time doing that. It's not easy, as I said, but also we will need, this is a whole next topic function, which is a big part of the year, is the same kind of skills. They're working from an equation to graph and backward. So we're going to give it the respect it needs. Now, by now you should already start getting familiar with these graphs. So we'll start with the sine graph, the ray graph. Okay, start from 0, go up to 1, back to 0, minus 1, back to 0 at 360. Okay? I made a mistake here, didn't I? I know, sorry. I'm looking at the red. Yeah, the red is absolutely fine. Okay, so that's the sine, okay, just like a wave. Okay. We also mentioned the word period. Period means it repeats itself, and the period that it has is 360. Because if I take this 360 just from here to here, and I do copy and I do paste, it just repeats itself. So the period is 360. Cosine, okay, also has a period of 360. It repeats itself every 360 degrees. The shape is also similar, but instead of starting at 0, it starts at 1. It goes from 1 to 0 at 90, minus 1, 0 back to 1 at 360, and then it goes up again. Okay? They both have the same period. They have the same amplitude, which is 1. Okay? The amplitude is the difference between the maximum and minimum divided by 2. And that's about it. Okay? Then, okay, we'll just talk about that. We'll come back to how can we manipulate them. The next one is tan, which we spend the whole lesson on. It's more difficult. Definitely, for sure, more difficult. Okay? The way I do it, first of all, I draw the vertical asymptotes. And I remember that I have these vertical asymptotes at 90 and 270. Okay? And then the next one, I've got what I call the critical points, which are 45, 135, 25, and 315. Okay? In these angles, the value is either 1 or minus 1. 1, minus 1. Okay? So I plot these points first, and then I draw that shape, where it blows up to infinity here, okay? Minus infinity there, back to infinity, minus infinity, and so on and so on and so on. But let me ask you now, so far we spoke about all of that. If the period here is 360 for sine, cosine, what will be the period for the tan? Do you reckon? I'm asking you now, what will be the period for the tan? How many degrees do you have to go through until suddenly you get the same thing? What can I take with the first copy and then just paste it? Okay. If I say 360, okay, yes, I take that, okay, and then I paste. You see, you are right in the way that after 360, I'm repeating the same thing. Actually, it's less than that. Okay, you're right, Luke, okay? So check this out, right? When do I start going up here? Actually, 180. Look at this. If I take, let's say, this bit, this shape. Okay, from 0 to 180, it basically looks like this. Right? I should draw it a bit more here. I still see it. Right. So I'm going to take from 0 to 180. Okay, that's that bit. I've got the asymptote and that. Copy. Paste. And then I do another paste. Okay? Alright, I'll paste it with a different color so you can see. So I'm pasting it again. Okay? Pasting it again. And you see that I'm getting the same shape. So the periods of a tan graph, the period is actually 180 degrees. Okay? Where for sine and cosine, the period is 360. It's half the period. And I think that's worthwhile writing somewhere. Okay? I will leave that so you can copy it later. Okay? Okay, another thing they mention here is where are the asymptotes? Okay? And this is, again, the first time you guys write these things like that, but next year you'll use a lot of it. So where are the vertical asymptotes, where the graph always approaches but never really cross? Which degrees? Where do we see these vertical asymptotes? 90 and 270. The next one, do you think, will be at 540. In other words, it's 90 degrees plus 180k. So I'll keep on adding 180. K is basically like an integer. It's 0, 1, 2, 3. So it's 90, 180, then another 180. Sorry, 90 plus 180 is 270. Plus 180 is, hang on, you missed one. There was 450, I think. Okay? I don't know if you said 540 or 450. It should be 450, okay? So it's 90, okay, I'll write it down. 90, 270, 450, and then the next one will be actually 6 something. Every time we add 180. Okay? So this is two new things. We spoke about the period, and we spoke about when do we have the asymptote. I spoke about the special point, the critical point, and now I think I just need to talk, again, remind you something that we've done. Okay? I'll erase this, you don't need that, I'll just to show. Okay? If I've got y equal a sine x plus q, okay, we've done that. Okay, we've done that, but I just want to repeat it. Okay, the a. What is the a? The amplitude. Okay, we did talk about it. Okay, a. If it's larger than 1, it stretches. If less than 1, it compresses. But in any case, it's the amplitude. So when I don't have a, what does it mean? That a is equal 1. The amplitude is 1. Okay? If I have, I'm not going to leave it there, but if I have y equal a cosine x, then this is not going to be 1. It's actually going to be a. Okay? If a is negative, the graph is flipped. Okay? And the q, what did we call the q? Vertical shift. So if it's plus 2, the whole graph moves up 2. If it's minus 5, it goes down 5. So that's vertical shift. Okay. And then I want to, so this we mentioned. But one thing we didn't mention, 1 tan x plus q. Again, q is going to be vertical shift. The a, I can't talk about amplitude because tan doesn't have an amplitude. It doesn't have up and down, it goes up to infinity. It doesn't have a maximum value, right? Amplitude is the maximum value minus the minimum value. So I don't have that option, okay? So what is the a? Where would you find the a? I'll give you a second, see if you can figure it out. Where in the graph will we have a? I know it's a little bit of a funny question, so I'm not going to give you too much time. Anyone want to try? You're right, it is where that 1 is. It's the critical point. Okay, the critical points are basically where where the y is 1. Okay, so when x is 45 and 25, okay, tan x will be 1. But if I have y equal tan x plus q, if I have a here instead, a tan x, okay, then instead of the critical point, instead of them being 1, it's actually a. So what was 1 now will be a. Does that make sense? Okay. Right, there's a lot of stuff here. Okay? It's all stuff that we spoke about, except for the purpose. All stuff, there's quite a lot. So what I'd like you to do now is just work through the... I'm actually not going to do one with you. I want to see if you can do it by yourself. I'll pause the camera and I might just record another video later. Okay? Right, so we're doing exercise 13 from the beginning. Okay, chat, so we are doing page 97, exercise 13, and I'll just do A for you, and the rest you can do at home. I mean, not at home, you guys work here, but you can just check your answers as you go along. So I've got these two functions, f of x, which I drew as green, and g of x, which I drew as black. Okay? We can see there's, this is obviously a cosine. I can see I forgot the sign, isn't it? That's not mx, it's m sinus, sine x plus n. Okay, and they want us to write down the amplitude range of f. Okay, what's the amplitude? 1. Is it 1? Yes, it goes, yes, okay, good. So it swings between 0 and 2, okay? And somebody like me, for example, will very easily say the amplitude is 2. But it's not 2, you're absolutely right, it's, because how do we find the amplitude? It's the maximum minus the minimum or time half. So the amplitude is 1, okay? It swings up, 1, and down. Okay, so the amplitude is definitely 1, and then the range, okay, range is basically, what is the range? Is the possible y value. So it's anything between 0 and 2. Do I put square or circle? Square. It includes 0, it includes 2. Okay, you understand? It's a bit confusing because in stats, when we say range, we would actually mean 2. The range is the maximum minus the minimum, but ranging function is all the y values, possible y values. The same thing for g. Okay, for g of x, the amplitude. What will be the amplitude now? What will be the amplitude for the black graph? Swings between 2 and minus 2. So what will be the 2? It will be 2 now. Because it's 2 minus 2, which is 4, times half is 2. The amplitude will be 2. Can you see the difference? Georgia, you alright? Okay. Range, what will be the range? Okay. Between minus 2 and 2. Okay, Sina is with me here. I'm not sure about the rest of you guys. Come on. Okay. Determine the value of A and Q. This is now real stuff. Okay. Let's start with Q. Or let's start with A. No problem. Okay. A, we said, is the amplitude. So what will be A equal to? 1. Okay. So in other words, I don't even need to write it. Okay. Because A equal 1. Okay. 1 times cosine x is cosine x. And Q, and not seen that clearly. What will be Q? It's plus 1 because we shifted it. You're absolutely right. We shifted this whole graph. It was supposed to be here. 1 now it went up to 2. The minus 1 went up to 0. So plus 1. Perfect. Alright, the same thing I guess we need to do for M and N. Okay. What will be that? M equal to 2 because the amplitude we said is your M, is the constant before, the coefficient of the sine x. Okay. And N 0. Okay. When you don't have any vertical shift, so N is 0. Okay, that's it. Okay, so for you guys at home and for you guys, I'll just pause the video now here, but please carry on with the rest of the exercise in your own time. Okay, we've got a double, we should finish. Come on, guys.